Hi, welcome to Chapter 2, Theory and Models. Many times people think that theories aren't practical. Oh, that's just theoretical. But I hope that you'll see here that theories are actually really practical and really essential for gaining good evidence and using evidence, and that models, which are more precise articulations of theories, are especially important. The tools we're going to learn in this chapter of path diagrams or causal models are a tool that we will be using throughout the course. This is the first lecture of the Theory and Models chapter, part 1. And we're going to introduce theories and models, and we're going to spend a long time on the basics of causal diagrams or path models. Terms aren't exactly the same. We'll discuss that later. So what is a theory? Well, theories tell causal stories. What do we mean by that? A theory is about why something is the way it is. So that's what causal means, how and why things are the way they are. And also, as we've discussed, if one thing changed, how would something else be different? So why is crime the way it is? In this class, we're often going to focus on one cause at a time. So if we think about something like crime, there are tons and tons of things that affect the crime rate, whether and when various crimes are committed, by who, what type of crime, and so on. Lots and lots of things will influence that. Income, weather, age, other economic opportunities, all kinds of things. When we focus on one cause, we don't mean that's it, it's all due to that one thing. It's just that we're choosing to focus on that cause. And theories need to explain variation. Like, why did crime go down and down and down for decades? Why has it just recently, at least violent crime, rather murder, has gone up? The other ones haven't gone up. Why? So a theory should be able to explain variation. So some variation is variation over time. So this is looking at the rate of violent crime in Portland, how it was higher in the 90s, went up a little bit in 95, and then it's been going down a little bit up here. Okay? And again, up more recently. Why? Ideally, the theory would explain that variation. A good theory would also explain the cross-sectional variation. If you look at these cities, you see crime is particularly high in Baltimore and Milwaukee, lowest in El Paso. Among the cities we're looking here, chosen to be similar in size to Portland. So cross-sectional variation in this case means across cities, but the term in generally is across people or places or organizations. So it's like a single point in time looking across some unit. So more about what a theory is and particularly how it's valuable. Theories enable us to identify key variables. Like if we can think about what are factors driving crime, then we know, oh, we should measure those. And if we measure them, that'll help us gain evidence. And theories are also supposed to generate testable hypotheses. We're like, if our theory is true, this relationship should occur, and we can test it. In applied theory, our focus in this class, it tends to focus on modifiable variables, things that we could actually change with a different policy. Theories are also supposed to be positive, meaning the way the world is, not the way you want the world to be. So, but when we say the world here, the way the world is, we don't mean only descriptive research, we also mean causal research, but it's a true causal impact, not what we would like the impact of a program to be. Theories come from all kinds of sources. They come from practitioners observing the way things are. They come from academic, deeper theories from psychology and economics, making predictions about the way things happen in the wider world. They come about from reasoning from other theories. They come about in lots and lots of ways. So in this class, we're going to use a particular kind of model. And a model is a more specific way to articulate and communicate a theory. So you're familiar with models of a building, like architects will create a model of something they're going to build. The models we're going to use in social research, they're typically graphical or equations, and we're almost always going to use graphical ones. We're going to use a particular kind of model, which is used in a lot of causal research. So they're often called causal diagrams. We're going to have a variable, which is in a circle, such as engagement, and another variable, crime here. And a key thing is the arrow and the sign. So we're going to go through each of these things, but these are the basic components of this kind of model. And the one we're going to talk about is a theory of community policing. And the idea is that this particular approach of community policing will result in greater engagement by police in the community. And then the idea is, what effect does that have on crime? So the first component is the variable. And variables, this sounds trite, but variables must vary. They have to take on different values or attributes. So a quantitative variable like engagement, more engagement, less engagement, has to go both up and down. And variables describe someone or something. So in the jargon, that's a unit of analysis or a case. So, and this is kind of what like you learned in stats, right? So we have a variable like crime. And in this case, there's either committed a violent crime or didn't. And the unit of analysis is a person. So every line in a person, right? So this could be, and this would be like in Excel or Stata or SPSS. The unit of analysis is a particular person, and the variable crime, committed a violent crime, is yes, no, dummy variable, 0, 1 variable. But you could also have the city as the unit of analysis. And so then the variable crime isn't telling us about a person. It's telling us about a city, and in this case, a crime rate. So here we have from 2019 for Portland, 577 violent crimes for 100,000 people, Milwaukee, 1,475, and so on. So these are crime rates that apply to the city. So your variables are like in the column, and they're giving you information about the unit of analysis, whether it's a city or a person. So that's the crime variable. It's got to apply to some case. It can go up and down. It needs to vary. So in this example, in this model of community policing and crime, the direction of the arrow is telling us what causes what. So the arrow is incredibly important. In the next edition, I'm going to make that arrowhead much larger. I'm trying to do that in my talks than it is now, because that direction is incredibly important. So in this example, engagement is the cause, our independent variable. Crime is the effect, the dependent variable. And the idea is more engagement causes less crime. If the arrow went the other way, it would say more crime causes less engagement, which is not a crazy theory, but it's definitely a different one. So you could say, though, if people commit crime, they stay away from the police. We're going to talk about those kinds of issues in a much later chapter on causation. For now, we're just looking at our theory that more engagement of the police with the community lowers crime. So I cannot stress enough the direction of the arrow, which is a different issue than the sign above it, right? I said more engagement, less crime. That's a negative sign, means going in the opposite direction. That also means less engagement, more crime. Remember, the variables have to go in both directions. So minus sign doesn't mean crime goes down. It means that crime moves in the opposite direction of engagement. So again, positive sign means the cause drives the effect in the same direction. Negative means an opposite direction. It's really hard. People are like, plus it goes up, minus goes down. No, that's not true. And always check the relationships in both directions. So in this case, more engagement, less crime, less engagement, more crime. So a former student of mine came up with a great tool that seems to help people with the signs to remember the same opposite, and it's this with your hands. If it's a plus sign, the variables go in the same direction. More poverty, more crime, less poverty, less crime. If it's a minus sign, they go in the opposite direction. More engagement, less crime, less engagement, more crime. Positive, same direction. Negative, opposite direction. So the signs we were just talking about are signs in the model, the theory of what causes what. But causal relationships result in correlations or relationships in the data. So in this one, we would expect to see that a higher poverty area would be a higher crime area. Basically, as poverty increases, crime increases. With the opposite for engagement, that low engagement, according to our theory, should result in high crime on average, and higher engagement should result in lower crime on average. So the key model features, variables are the things we're learning about, crime, engagement, and so on. They have to take on different values and attributes, which means they go both up and down. And they have to be about someone or something. That's the unit of analysis or the case. The direction of the arrow is critical. It says what is affecting what. It's a central part. The sign is whether that impact is in the same direction or the others. So finally, what is this path diagram versus causal diagram? In early editions, we use the term path diagram. And that's the traditional term for the kinds of things we're talking about in this in this chapter. Theories of mechanisms, which we're about to get into, and so on. Causal diagram is a later term, and it's used for the kinds of things we're going to do in the second half of the chapter, sorting out what causes what and so on. And as we talk about in the book, and we'll talk about a little more in the second half of the course, there's a particular type of causal diagram which is very, very rigorous. DAGs, they're called. So just know that's where we're going. And we decided to use the term causal diagram even for these things which are sort of older approaches as well. So now, I was just mentioning correlations. You learned about correlations in statistics. So that's like we look at a data set, perhaps a cross-sectional data set of cities or neighborhoods, and we learn that where asthma is higher, crime also tends to be higher. That's a pattern of association that we observe in the data. It's not a causal relationship. It's not telling us that asthma causes crime or crime causes asthma, or that some other factor or set of factors is driving both asthma and crime. It's just a correlation. That's important. It's extremely important evidence. But you don't want to confuse it with a causal one. So in the diagrams, we depict it with these dotted lines with no arrow. There's no arrow because we don't know what's causing what. The sign is the same as it was before. They move in the same direction. So where asthma is above average, crime is above average. Where asthma is below average, crime is below average. On average, not in every single place, on average. So we'll spend a lot more time on this later, and we're going to spend a lot of time on how we can use correlations to try to learn about causal relationships. For now, just remember they're not the same thing. Because what we are going to focus on now is causal mechanisms, right? So supposedly this community engagement, police engaging with the community, is going to reduce crime. Well, why? Why should it do that? Why should we believe that? We're going to use this model to illustrate why we think that might be true, and we do that with intervening variables, which trust is. It's an intervening variable, sometimes called a mediator, and it's an explanation of the mechanism. So according to this, more community engagement, more trust, okay? So these variables should mostly be about the community. So the trust is the trust that a community member has with police. So the idea is the police engage with them, the community members trust them more. And the idea is more trust is going to be lower crime. You might think, that's not a very complete theory. And I would have to agree with you. And later on, we're going to talk about more complete theories. And in fact, we're going to make it slightly more complete right now. So instead of just having one mediator, one intervening variable, we're going to have two. This one says more community engagement, more trust. If the community trusts the police, they're more likely to cooperate with the police, and that, the idea is, will bring down crime. So now this theory of community policing that involves greater engagement with the community and why you think that should reduce crime has been spelled out more. The intervening variables tell us how and why we believe this will happen. And together they form a mechanism. A mechanism is a chain from your independent variable in blue to your dependent variable in fuchsia. And here we're spelling out in yellow how we think that happens. And of course, you always want to go through both directions. Less community engagement, less trust, less cooperation, more crime. Another, we're going to spend a lot more time on mechanisms and how to dig a lot deeper than this example, but in this video, we're mostly focused on giving you the tools themselves. The final tool we want to give you is a moderator. A moderator is a variable that affects the magnitude of the link of a relationship. So you might ask, well, how much will community engagement reduce crime? So our theory is that more community engagement means less crime, but how big is that effect? And a moderator is a variable that affects the magnitude of that relationship. So in this case, we have a theory that the diversity of the police is going to increase the magnitude of that effect. And especially the idea is if the police contain officers from the same background as various community members, that community engagement will be more effective in reducing crime. So you might or might not agree with this theory. I should have said that earlier, but it's, after all, it's a theory. But again, a lot of times people think that the context and other factors will affect the magnitude of this relationship, and you show that with a moderator. And in data, the counterpart of such a moderator is an interaction variable, which you may have learned about in statistics. So in the next video, we're going to talk about logic models and how to go much more in depth and probing with causal mechanisms.